Welcome to Maths for All. This is Higher Level. I'm Aisling Flynn and we're looking at complex numbers transformations. So transformations on the Argand diagram. A transformation, meaning a change, can be a translation, which is a sliding movement on the graph. It can be a dilation, which is stretching or getting longer. It can be a contraction, which is getting shorter, or it can be a rotation, a turning effect, and a rotation can be clockwise or anti-clockwise. Okay, so first we're going to look at adding complex numbers. We're going to let w be the complex number 1 plus 2i. We're going to add it to a number of other complex numbers. Okay, so we're going to start with a, which is this red dot here on my Argand diagram. Okay, if I can write a. Okay, there's a. And we're going to add w to it. W is 2 plus 3i, so 2 steps to the right, 3 steps up, and we end up here. Okay, at 2 plus 3i. So the second dot here is a plus w. So, and you can see that a has moved 1 to the right and 2 units up. Okay, next we're going to start with b, that's that blue dot here. Okay, and we're going to add w to it, so that brings the complex number b plus w to minus 1 plus 5i, which is up here. So this dot here is b plus w, so it has moved 1 step to the right and 2 steps up. Okay, and finally we'll try it with c, which is minus 3i, which is down here. And we're going to add w to it, brings it to minus 2 minus I, which is here, the yellow dot. So that's c plus w. And if we look at the 3 arrows from the starting point, A, B and C, to when we added w, you can see that they've all moved the same direction, the same amount. So this is a sliding movement, so this is called a translation. Adding a complex number results in a translation or a sliding movement. Now multiplying complex numbers by a constant. So a constant is a real number and it never changes. Okay, so just regular numbers with no i's involved. Given the complex numbers below, multiply them by a constant. So starting with a, okay, so here's my a, 2 plus I. There's a. We're going to show you the arrow back to the origin, okay, which gives the direction and also the magnitude or modulus of a. And we're going to multiply a by 2. So 2a equals 4 plus 2i, which is out here. Okay, so that is 2a. And using the arrow there to show that, can you see that it is in the same direction? Okay, my arrows aren't the straightest, but yeah, it should be in the same direction. Okay, let's look at b, minus 1 minus I, so this is b. And we're going to multiply it by 3. I get minus 3 minus 3i, so this is 3b. And it ends up in the same direction, but 3 times longer. Okay, and finally let's look at c, which is here in the blue. And we're going to multiply that by 2.5, 2.5, and I end up at minus 5 plus 5i, which is out here. So that's 2.5 times c. Okay, again, same direction, just longer, 2.5 times longer. Okay, so what do we call this? Multiplying by a constant greater than 1 results in dilation or stretching. So the direction stays the same, but the arrow got longer. That's called dilation. Okay, what happens when you multiply by a constant, but a constant less than 1? Okay, so let's take d, which is 4 plus 4i. Okay, there we have d on the Argand diagram. And let's multiply it by a half. And I get 2 plus 2i, which is this purple dot here. That's half d. and you can see that the direction doesn't change, but the arrow is shorter. Multiplying by a constant less than 1 results in contraction, or getting shorter. Now, what happens when we multiply numbers by I? So we're going to try it and see what it looks like. So we'll start with complex number A, okay, which is 2 plus I. Multiplying it by I, you get 2I plus I squared. Of course, I squared becomes minus 1, so we get minus 1 plus 2I as the result. And there we have it plotted, and this is I times A. Okay, let's try it with a different one, and we'll figure out what's happening. So minus 1 minus I is down here, so this is B. And multiplying it by I, we get that. Again, remember that I squared gives minus 1, and minus 1 gives me that plus 1, so 1 minus I is the result, which is over here, which is I times B. Okay, and one more time, we'll start with C is minus 2 plus 2I is here, and multiply it by I, and recall that I squared is minus 1. Okay, we get minus 2 minus 2I, which is here. So that's I times C. So let's examine all of those. Can you see that the arrows do not change length? So A and IA are the same lengths or same modulus, but it seems to have had a turning effect. Right, so it seems to have rotated with 0, 0 as the center. Okay, it seems to have rotated. B rotated round to here, and C rotated round to here. Okay, so we get a turning effect by multiplying by I. How much of a turning effect? It seems to me to have turned by 90 degrees. Okay, that's a right angle, that's a right angle, and that's a right angle. And also it has turned this way, okay, which is anti-clockwise. All right, so multiplying by I results in rotation anti-clockwise by 90 degrees. So there's 3 pieces of information in that description. There's rotation firstly, then anti-clockwise gives the direction, and by 90 degrees by how much? Now multiplying two complex numbers, that's what we'll look at next. We've got A here, okay, so that's A. We've got B here, that's B, and A times B, so you have a 2 by 2 multiplication, working that out. Again, remember that anytime we see I squared, it's minus 1. So we get 2 plus 7i minus 3. We get minus 1 plus 7i, okay, which is off the scale of my graph. Okay, so this is A times B. Alright, so you can see that that arrow is longer than the individual arrows, and we have had some degree of rotation as well. So multiplying results in rotation and dilation. Okay, and we wouldn't be asked in this case to give the magnitude of rotation or dilation. Okay, that's enough. Okay, so let's now look at I and what happens when we multiply by additional i's. So we have the real and the imaginary axis here. Remember, this is I, 2i, minus I, minus 2i. Here's my real axis, 1, 2, minus 1 and minus 2. Okay, let's see what happens. So plotting I is just straight up there. Okay, 1 unit straight up. Multiply I by I, and you get I squared. And of course, I squared is equal to minus 1. Okay, so I squared is here. So this was I squared. Now multiply I squared by an additional I, and we get I cubed. So I get minus I, which is straight down, that's I cubed. And multiplying I cubed by an additional I get minus I squared, which is minus minus 1, which of course is plus 1. So I to the power of 4 is plus 1. So we see we get this rotation of the arrow 90 degrees every time with each additional I. Okay, plot the complex number z equals 6 plus 2i on the Argand diagram. So if we take each box as being one unit, and this is the real axis, 1, 2, 3, 4, 5, 6 plus 2i up 2 units. Okay, my pen doesn't like dots. Okay, this is z. Okay, all right, that's z. And we're asked to, and that's to rotate it basically. Maybe it might help to do an arrow. Yeah, that's better. Rotate it by multiplying by I. Okay, now we can actually do this without calculating each time. If you remember the previous one, we rotated by 90 degrees, means the 2 and the 6 will interchange. 2, 4, if we keep the scales the same on both axes, IZ will be here. It'll be back 2 units, excuse my curved lines, and up 6. So IZ, reading off my graph, will be minus 2 plus 6i. Now you can verify that by doing the multiplication if you wish. Now where would I squared z be then? Well, let's rotate it by another 90 degrees. So again, the 6 and the 2 tend to interchange. So we'll be back here minus 6 and we'll go down 2. Okay, so here. So this will be I squared z. If we read it off the graph, it'll be minus 6 minus 2i. Okay, and one more time. Okay, for I cubed z, let's rotate it again, we'll be going to here. Okay, again, excuse my lines, that's dreadful. Okay, so this will be I cubed z, and it would be plus 2 on the real axis minus 6i. So they're all very close to each other. If you were to calculate the modulus of all of them, they'd be equal, so the same length. All right, okay, let's rotating look at this by 90 degrees exercise time. Now, using the Argand diagram below, write down the complex numbers z1 and z2. So z1 equals 4 plus 3i, z2 is equal to minus 3 plus 4i. Okay, question 1 down here, show that z2 equals iz1. So iz1 equals I times 4 plus 3i, which is 4i plus 3i squared. That's minus 1. I get minus 3 plus 4i. Okay, now how else might you have done it if you want to do it graphically? Well, multiplying by I rotates z1 by 90 degrees, doesn't it? And you would end up at z2. Okay, now which of the points z3, z4 or z5 represents I squared z1? So we've just rotated it by 90 degrees by multiplying by 1i, and we got to z2. If we rotate it by another 90 degrees, firstly we'll be 180 degrees from where we started. Okay, we end up at z5, so that's I squared z1. Okay, so the answer is z5. Okay, now if z6 was I cubed z2, find z6 in the form of a plus bi. So let's start with, it's starting with z2 and multiplying by I cubed. So multiply by 1i, we go 90 degrees to z5. Multiply by a second I, we'll end up down here, I think. Okay. Yeah, okay. That's, so we'll have multiplied Z2 by I squared, we go by 90 degrees 2 times, and if we go again by 90 degrees, where do we end up? We end up at Z1. Okay, so I can say that Z6 equals 4 plus 3I. Okay, now, so this is an exam paper question. It comes from the 2014 paper 1 for higher level. And this is where we use a bit of detective work. So we have 4 complex numbers, Z1, 2, 3 and 4, shown in the Argand diagram, and these are they satisfy the following conditions. So this is the information we're given. Z2 is IZ1. Z3 is KZ1, where K is element of R, so that's multiplying by a constant. Okay. And Z4 equals Z2 plus Z3. The same scale is used on both axes. Identify which number is which by labeling the points on the diagram. So a bit of detective work. Now I always find it useful in these questions to take a ruler, now you'll have a ruler, and join up each number back to the origin. Okay. Now excuse me for my lines, alright. Okay. So you don't necessarily have to start with the first piece of information. For example, the second piece here, I can tell that it's multiplying by a constant, so that's either dilation or contraction, depending if Z is more or less than 1. So I can tell straight off that Z1 and Z3 are this pair here. Okay, but right now I don't know which one is which. Okay, so we'll bear that in mind. Okay, Z2, we'll start with the top piece of information. Z2 equals I Z1. Now we learned that multiplying by I gives rotation by 90 degrees. Okay, now we're told that the same scale is used on both axes, so we should have 90 degrees. Now which two lines look like they're at 90 degrees? Well, there's my 90 degrees, I think. Z1 will be the starting point. Okay, so and the length of the line shouldn't change, so I think this one here is Z1. Okay, it's the starting point. When I multiply it by I, which means rotate anti-clockwise by 90 degrees, I should end up at Z2. So I think that one there is Z2. Okay, so that leaves, okay, already I said that Z1 and Z3 should be in the same line. Okay, because they're multiples of each other. So that means this one here is Z3. Notice Z3 is shorter than Z1. Okay, so that was a contraction. And then what's left but Z4, right? Now let's use the last piece of information just to reassure ourselves that we're right. It says that Z2, so if I come out this direction along Z2 and I add Z3, so Z3 goes in this direction, this distance, so that's Z3. So adding Z2 plus Z3 would leave me at Z4, so I'm happy that I've made the correct choices. Okay, and that's called a translation there, where you add, isn't it? So the arrows go end to end and you follow the arrows. Okay, now, so I think I've done question 1 correctly. Write down the approximate value of K. So we said Z3 is shorter than Z1, so K was less than 1. I'd say it's about a half. Okay, the word approximate is used, so if you're slightly